Yes, my dear students, some of the important reactions for the carboxylic acids. For carboxylic acids, we have to discuss now. Chemical properties of chemical reactions of chemical reactions of carboxylic acids. Carboxylic acids. That is, first one, reduction of carboxylic acids. Reduction of carboxylic acids. Carboxylic acids. Reduction of carboxylic acids. What are the reagents we are using for the reduction of carboxylic acids? Reagents. Which reagents we are using? Reagent number 1, reaction with hydrogen in the presence of a nickel. So number 2, lithium aluminum hydride. Lithium aluminum hydride or diborane B2H6 in the presence of tetrahydrofuran. Tetrahydrofuran. That is second reagent. Then third reagent that is hydrogen iodide in the presence of red phosphorus. These three reagents we are using for the reduction of carboxylic acids. So what happens once these reagents when we are using for the carboxylic acids? RCOOH, carboxylic acid. If we use which is hydrogen in the presence of nickel, if we use, then one more lithium aluminum hydride if we use, then one more B2H6 in the presence of THF, tetrahydrofuran if we use. Then these three cases, carboxylic acid can be converted into alcohol. Carboxylic acid can be converted into alcohols. All these cases are CH2OH. Then the third reagent that is hydrogen iodide in the presence of red phosphorus, that will be converted into alkanes. Alkanes, CH3 like this. So these three reagents convert. These three reagents converted into alcohols. Then this reagent can be converted into alkanes. So this is a reduction of carboxylic acids. So in the reduction, what happens? Carboxylic acid can be converted to alcohols in the presence of hydrogen, nickel, then lithium aluminum hydride, then diborane THF. Then only the except hydrogen iodide and red phosphorus can be converted into alkane. Sir, if you use sodium borohydride, what about the sodium borohydride? NaBH4 if you take sodium borohydride, aldehydes and ketones can be converted into alcohols, but not carboxylic acids. That you have to remember. Now, so one of the application we have to see. Based on the reduction of carboxylic acids. See what is the application. So that is the question is benzoic acid can be converted into benzoic acid can be converted into benzyl alcohol. benzyl alcohol in the presence of in the presence of in the presence of following, which are the following reagent? In the presence of which of the following reagent? Which of the following reagent? Which of the following reagent? So such type of questions they will ask. So that is option number 1, lithium aluminum hydride they will ask. Then option number 2, hydrogen in the presence of nickel they will ask. Then next B2H6 diborane in the presence of THF tetrahydrofuran they will ask. Then fourth one, all of these they will ask, all of these like this. So all these three reagents can be converted into alcohols. Benzoic acid, what benzoic acid? Benzene attached with COOH. All these reagents that can be converted into CH2OH. So in this reaction, the redox reaction, so that is, which is COOH group can be converted into CH2OH group. That's what you have to remember for the reduction of carboxylic acids. So next, one more important reaction, that is Schmidt reaction or Schmidt rearrangement. Second reaction, Schmidt reaction or Schmidt rearrangement. Second one, Schmidt rearrangement. Schmidt rearrangement. So what is the Schmidt rearrangement? Sir, here carboxylic acids reacts with hydrozoic acid, that is N3H, to form our primary amines. This reaction takes place in the presence of concentrated H2SO4. This is the reaction. What is that? Schmidt reaction. In this reaction, what happens? Conversion of carboxylic acid into amine NH2 group. Carboxylic acid into amine group, NH2 group. That you have to remember. Which reaction? Schmidt reaction or Schmidt rearrangement we call. Sir, for example, RCOOH, when it is reaction with the hydrozoic acid N3H in the presence of what I told, concentration H2SO4, that will be converted into what I told, primary amines. What we call primary amines. Then plus, sir, CO2 gas will be released from it. Then N2 gas also will be released. So based on this general equation, in the place of R, if you take CH3, then we call it is acetic acid, CH3COOH. Sir, CH3COOH, when it is reaction with the hydrozoic acid in the presence of same concentration H2SO4, then it will be converted into CH3, then NH2, methylamine or methanamine. Methylamine is a common name, methanamine is IUPAC name. Then plus CO2 plus N2, nitrogen gas will be produced. So now, how does this reaction takes place? So we'll see in the mechanism. So look at the mechanism. mechanism, if you take, sir, first what happens if in case if you take carboxylic acid, R C double bond O OH, sir, in the presence of H plus, in the presence of H plus, then R C double bond O. So look at, sir, O, sir, here lone pair of electrons are there. These lone pair of electrons are attack on the H plus. Then what happens? Then here H, then here H, then positive charge will be formed. Right, clear all of you? Now what happens? We can expect that H2O will be released. H2O will be released. So H2O will be eliminated from the molecule. Then R C double bond O plus, like this will be formed. That is acyl or acetyl. So in case in the place of R, if you take CH3, acetyl carbocation will be formed. Next, what happens? This carbocation RC double bond O plus, RC double bond O plus, then plus N3H. Sir, N3H structure generally, then N bond N, triple bond N, then here positive charge, then here negative charge, then H will be there like this. Sir, of course, in the hydrojoic acid, whatever the negative part is there, it will be attached to the carbonyl carbon or where the positive charge is there. Then resulting what happens? Look at, then R C double bond O, C double bond O, N will be attached to there, N having H, then N triple bond N, then positive charge is there here. Look at all of you. Now what happens? Here rearrangement I told, rearrangement nothing but one group in the same molecule, one group, it can be displaced from one atom to another atom, or it can be migrate from one place to another place. That we are calling rearrangement. So even here also, alkyl group can be migrate from the carbon atom to nitrogen atom, So once if it is shifted, then here in between the nitrogen, whatever the bond is there, that will be shifted towards the nitrogen atom because of positive charge. Right. Then here we know that lone pair of electrons are there. This lone pair of electrons shifted towards in between the carbon and nitrogen as a double bond. Then what happens? Look at, once bond is shifted towards the nitrogen, N2 eliminate as N2. Clear? Right. Now alkyl group, it is shifted to where? Nitrogen atom. Yes, it is attached to the nitrogen. Nitrogen has even hydrogen atom also, right? Yes. Then once lone pair of electrons are shifted towards that, then double bond will be formed here. Double bond, then C, then double bond O, like this will be formed. Here positive charge is there. Positive charge. So now this hydrogen atom when it is shifted to there, then H plus will be escape out from there. H plus will be escape out. Then finally what happens? Look at, R N double bond C double bond O. This is the name we call alkyl isocyanate. Alkyl isocyanate will be formed. On hydrolysis, nothing but addition of water to this. Sir, here it will be break. So observe it carefully, where in between the nitrogen and carbon, where the double bond is there, it will be break. Then oxygen attached to there, then hydrogen attached to here, like this. Then what happens? R bond NH2 plus, then CO2 will be formed. Clear all of you? So finally, what is formed? Amine. This is called Schmidt reaction. Right. Now what type of questions they are asking based on this Schmidt reaction in the examination, like JEE mains and advanced and as well as NEET in the examination? So actually in the NEET examination, they won't ask mid reaction because it is out of the NCERT textbook. But in the JEE mains and advanced, they will ask a question based on Smith reaction. So see once what type of applications they are asking. Right. So one of the application is given like this. Phenol is there. Phenol. Phenol when's reaction with CO2 in the presence of what? NaOH. Then H plus. This is first, then second reagent. Then A will be formed. So A when it is reaction with hydrozoic acid N3H in the presence of H plus, nothing but concentration H2SO4 or something, any mineral acid. B will be formed. Okay, right. B will be formed. So what is the A and B? So here from phenol, phenol can be converted into this reaction we call generally coal base reaction. Coal base reaction. Coal base reaction. See coal base reaction phenol when it is reaction with a CO2 in the presence of NaOH, then H plus it will be converted into salicylic acid or orthohydroxybenzoic acid COOH. Orthohydroxybenzoic acid. Benzoic acid. This is sorry, A compound it is. Further reaction, it is a Smith reaction. This is the coal base reaction. This is Smith reaction. Smith reaction. Sir, COOH group can be converted into CH2OH. CH2OH when if you use hydrozoic acid N3H, then in the presence of H plus. So such type of questions they are asking in the examination based on Smith reaction. Next, one more famous reaction and important reaction based on the chemical properties of carboxylic acids. See what type of reactions they are asking. Say what's that famous reaction I told? That is HVZ reaction. HVZ reaction. HVZ reaction. Hell-Volod-Zelensky. Hell-Volod-Zelensky reaction. Sir, what is the HVZ reaction? Carboxylic acids. Carboxylic acids having at least one alpha hydrogen atom. One hydrogen atom reacts with halogen. In the presence of red phosphorus to form alpha halo carboxylic acids. Alpha halo carboxylic acid. This is HVZ reaction. What is that according to the statement? Carboxylic acid must be contain at least one alpha hydrogen atom. What is the alpha hydrogen atom? Sir, when carboxylic acid, this is the carboxylic acid group. Functional group attached carbon we call alpha carbon. Once alpha carbon having hydrogen atom, then we call alpha hydrogen atoms. Sir, carboxylic acids once reaction with a halogen, any halogen like chlorine, bromine. Sir, in the presence of red phosphorus, I told, yes, red phosphorus. Then what happens? Sir, in the place of alpha hydrogen atom, then halogen will be attached, COOH as usual will be there. Sir, even here, then further reagent hydrolysis we are using. The first reagent is this, so the second reagent is this, alpha halocarboxylic acid. Then what will be eliminated from the compound? HX will be eliminated from the compound. Sir, for example, in the place of R, if you take CH3, then CH2, then COOH, then the same reagents if you use. Sir, or otherwise in the place of X2 chlorine we are using a red phosphorus followed by hydrolysis, nothing but addition of water. Then what happens? Sir, CH3, then CH, then chlorine, bond COOH, then plus HCl will be formed like this. Sir, what happens there? In the place of alpha hydrogen atom, chlorine is attached. Okay, clear, right. Sir, how does reaction takes place? So let's see the mechanism. In the mechanism, we'll see how does reaction takes place. Say a mechanism, if you observe, first what happens? RCH2 C double bond O OH. Yes. Here red phosphorus in case for example any halogen X2 when you use, then PX3 nothing but PCl3 or PCl5 like this will be formed. PCl3 or BBr3 or PI3 will be formed. We know that already once PX3 when it is reaction with that, in the place of OH halogen will be substituted. Yes. Or CH2 C double bond O. So in the place of OH what I told, X will be formed. Okay, clear, right. So next here if you observe, enol formation takes place. H2, sir, one of the hydrogen atom if you take there, sir, in between carbon and hydrogen bond will be shifted to in between the carbon. Then in between carbon hydrogen bond will be shifted to there, resulting what happens, look at R CH double bond COH, then bond X will be formed. Now when it is reaction with a halogen X bond X, here bond will be shifted to there, then double bond, one of the bond will be shifted to, one of the bond will be attached to there, as a nucleophile it will be attack on it, so that X will be eliminated from the here. Sir, X then hydrogen atom it is eliminate as HX, then R CH, then halogen atom attached to this carbon itself, then C double bond O, then X will be formed. Now when it is reaction with H2O, then what happens? R CH X C double bond O. Sir, hydrolysis, once if you do the hydrolysis, bond will be break here, sir, OH will be attached to there, then H will be attached to there, then here finally OH will be formed, then HX will be eliminated. So this is a very famous reaction, HVZ reaction, Hell-Vollard-Zelensky reaction. So based on this reaction, what type of questions they are asking, once look at. So what happened there? In this reaction, alpha hydrogen atom can be replaced. For example, acetic acid, if you take CH3COOH, alpha hydrogen atoms are there or not? Yes, is there. How many are there? 3 are there. So generally even at least one alpha hydrogen atom also is there, then reaction takes place. Is that involved in the HVZ reaction? Yes, definitely it will be involved. Then in case CH2X or CH2Cl already is there, then COOH, is that involved in the HVZ reaction? Yes, because 2 alpha hydrogen atoms are there. Then in case Cl3COOH, so now this, it won't involve in the HVZ reaction. It won't involve. Why? What is the reason? Because there is no alpha hydrogen atoms. Then one more. CH3 then CH3, then CH3, COOH is there. Is that involved in the alpha hydrogen atoms? Is that involved in the HVZ reaction? No, because alpha hydrogen atoms are not there. Sir, benzoic acid if you take, even benzoic acid COOH, it is not involved in the HVZ reaction. So which are involved in the HVZ reaction? Sir, they same benzene ring. Once if it is attached to the CH2, then COOH will be there. Is that involved in the HVZ reaction? Yes, involved in the HVZ reaction. Reason? Because alpha hydrogen atoms are there. Alpha hydrogen atoms are there. So alpha hydrogen atoms are there, then only HVZ reaction involves. Otherwise, it won't involve. Okay? Clear? Right. Now, based on this, one of the application we'll see what type of applications they're asking this question. So look at carboxylic acid COOH. When it is reaction with red phosphorus, then bromine is there, plus bromine, followed by H2O. Then A will be formed. A when it is reaction with alcoholic KOH, they're asking question. B will be formed. B when it is reaction with lithium aluminum hydride. Lithium aluminum hydride. Then C will be formed. C when it is reaction with a PCC, pyridium chlorochromate. Then D will be formed. So what is the A, B, C, D? What are the A, B, C, D? They're asking question like this. Sir, first we know that this is HVZ reaction. HVZ reaction. Is that involved? Yes, involved. Because alpha hydrogen atoms are there. Yes. These are the alpha hydrogen atoms. One of the alpha hydrogen atom replaced by bromine. Replaced by bromine. So that A we can get it is alpha bromo, then carboxylic acid like this. Then next what is there? Alcoholic KOH. Reaction with alcoholic KOH. Alcoholic KOH act as a dihydrohalogenating agent. Hydrogen, halogen eliminated from the adjacent positions. Sir, here halogen should be eliminated. Here hydrogen should be eliminated. Then both, sir, minus HBr will be eliminated from the compound. Then double bond will be formed. COOH like this. Then next, what is there? Lithium aluminum hydride. Lithium aluminum hydride, now only we are seeing. Lithium aluminum hydride can be converted into what? Carboxylic acid. Yes, carboxylic acid. So double bond as usual will be there. Then CH2OH will be formed. CH2OH. Next to PCC is there. PCC. Once reaction with a PCC, alcohol can be converted into aldehyde. Alcohol can be converted into aldehyde. So like this, such type of applications they are asking in the examination. You have to remember, dear students. So this is HVZ reaction. Next to, sir, heating effect on dicarboxylic acids. Heating effect on dicarboxylic acids. Right. So heating effect on dicarboxylic acids. Heating effect on dicarboxylic acids. Sir, first dicarboxylic acid, COOH, bond COOH. This one we call oxalic acid. Oxalic acid. The next carboxylic acid, CH2, COOH, bond COOH. Then malonic acid. Then CH2, bond CH2, COOH, bond COOH, succinic acid. Then next CH2, bond CH2, then COOH, glutamic acid. glutamic acid. CH2, then CH2, then CH2, then CH2, then COOH, then COOH. This we are calling adipic acid. Adipic acid. Oxalic acid, malonic acid, succinic acid, glutamic acid, adipic acid. To remember all these, to remember all these carboxylic acids, simply, so you can remember that OH, my malonic acid, my succinic acid, sweet, glutamic acid, good, adipic acid, apple, So you can remember simply, you can remember, it is a shortcut to remember the all dicarboxylic acids. Oh my sweet good apple, oh my sweet good apple. O nothing but oxalic acid, M nothing but malonic acid, S nothing but succinic acid, then G nothing but glutamic acid, A nothing but adipic acid. Okay, whatever it may be. On heating these reactions, how does these are convert? Sir, first one, oxalic acid on heating. Oxalic acid, COOH, bond COOH. Which is oxalic acid? This is oxalic acid. Oxalic acid on heating. Look at, observe it carefully, what happens. Sir, here first H2O will be eliminated on heating. H2O will be lost. Then after CO2 will be lost. CO2 will be lost. Then after next what is there? CO plus CO will be lost. So CO2, CO, then H2. Then here if you take on heating, which is this? O after my, nothing but malonic acid. Malonic acid. So in the malonic acid, so look at CO2 will be eliminated. CO2, only CO2 will be lost. Only CO2 will be lost. Remaining what is there? CH2H, CH3. Then COOH, acetic acid, plus CO2. Only CO2 will be lost from it. Then next, this is, which is, oh my sweet, succinic acid. Sir, succinic acid if you take, then anhydride will be formed. Anhydride, nothing but H2O only will be escape out from it. Anhydride, absent of water. So H2O will be lost on heating. So that CH2, then bond CH2, then bond C double bond O, then bond C double bond O. C double bond O, C double bond O. In between, oxygen will be there. Cyclic anhydride will be formed. Next, if you take, even this is also H2O will be lost. On heating, H2O will be lost. H2O will be lost. Then, what happens? Sir, CH2, bond CH2, CH2, bond CH2, then C double bond O, then C double bond O, O, acetic anhydride will be formed. Okay, this is malonic acid, acetic acid will be formed. Then succinic acid, anhydride, even glutamic acid also anhydride. Then next, if you take adipic acid, what is the adipic acid? Look at CH2, bond CH2, bond CH2, bond CH2, then COOH, then bond COOH. Sir, here on heating, H2O will be lost first. H2O will be lost. Then even CO2 also. So which are lost? H2O will be lost. Then CO2 also will be lost. Sir, first oxalic acid CO2, CO, H2O. Second malonic acid CO2 only will be lost gas. Then here H2O and here H2O. Then adipic acid Sir, OH, H2O will be OH, H2O will be last. CO2 will be last. Then finally, look at 1, 2, 3, 4, 5. 500, 5 membered, then C double bond O. 5 membered cyclic ketone will be formed. Cyclic ketone will be formed. Cyclopentanone. Cyclopentanone. Okay. So these are the chemical properties. So thank you.